Hi students, today we will discuss the interference of two light waves and what will be the resultant intensity at any point due to the interference of two waves. So you know, whenever a number of waves are interfering with each other, then at any point the resultant displacement that will be equal to the sum of the displacements of all the interfering waves at that point. So this is according to your principle of superposition. So now you see here, suppose हम दो वेव कंसिडर कर रहे हैं, एक का डिस्प्लेसमेंट है a1 साइन ओमेगा टी, दूसरे का है सपोज दैट इज a2 साइन ओमेगा टी प्लस फाइव. So these two waves are differing by a phase difference of phi. So now when they are superposing with each other, so the resultant displacement according to the principle of superposition, this will be equal to y1 plus y2, right? So now mathematically we can find out here, this will be your a1 sin omega t plus this will be your a2 sin omega t plus phi. Here you see this will be a1 sin omega t plus this will be sin a plus b, that is sin a cos b plus cos a sin b. So this will be as sin a cos b plus cos a sin b, right? So this will be the formula for the sin a plus b. Now rearranging the things, you can find here, this will be a2 cos pi sin omega t, this is sin omega t. So sin omega t I can take common. So here I will be getting your a1 plus a2 cos phi, and this will be equal to sin omega t. Similarly plus, we will be getting this term now. This will be a2 sin phi cos omega t, right? Cos omega t. Now you see, suppose for this value I am assuming, let this is your a cos theta, this is your a cos theta. Similarly you assume this one as a sin theta, right? This is the assumptions. So now what we are getting, we are getting this one as a sin omega t cos theta plus this will be a cos omega t and sin theta. So you know this is sin a cos b plus cos a sin b. So the formula will be sin a plus b. So here we will be getting a sin a plus b, right? So this is the resultant displacement of any particle when two waves are interfering with each other. So from this is you see how to find out the value of a and how to find out the value of theta. So now you see here, by taking the a cos theta and a sin theta, they are square. You see here, suppose we are considering your a sin theta square plus a cos theta square. So here we will be getting, for a sin theta I can write a2 sin phi square plus for a cos theta I can write here a1 plus a2 cos phi whole square. So this will be a plus b whole square. So this will come as a square plus b square, right? Plus 2ab, right? So now you see here, we can write this one as a2 sin square phi and a2 cos square phi. So if I take a2 square common, so this will be sin square phi plus cos square phi. Sin square phi plus cos square phi will be 1. So here we can write simply, this is a1 square plus this will be a2 square, that will be 1. So a2 square, and this will come as 2a1 a2 cos phi, right? Here you get this value will be a square sin square theta plus a square cos square theta. A square will take common, so sin square theta plus cos square theta will be 1. So here the value will be a square. So finally what we get, the resultant amplitude of the two interfering waves, that will be equal to the square root of a1 square plus a2 square plus 2a1 a2 cos phi, right? So this is the derivation for the resultant amplitude. Now you see what is the intensity. So intensity of a wave, that is directly proportional to the amplitude. Already we know that thing. So here you take, suppose your intensity I, that we'll get here, this I is directly proportional to amplitude. So if I write the value of I, so this will be a constant multiplied, this will be a square. So the similar transformations we will be doing here to find out the intensity relationship. So you take here, multiply k both sides and square. So here we will be getting k a square will be equal to k a1 square, right, plus k a2 square, plus this will be 2, we'll write k both sides. So here I can write this one as k. Now a1 a2 I can write as a1 square and a2 square root, right, and this will be cos phi. Now you can see here this k also will be taken outside like k square. So here k square means k a1 square, k a2 square. So finally what we will be getting here, we will be getting this one as I1 plus this will be as I2, and this will be equal to 2k square a1 square, k square, that is a2 square. So here we get k a1 square, that is I1, and k a2 square, that is I2. So here this will be the square root, and we get 2 here. Now cos pi. So this is the resultant intensity at any point when two waves are interfering at a particular point. Clear? So here you see the intensity will be maximum when the value of this cos phi will be maximum, right? And similarly the intensity will be minimum when the value of the cos phi will be minimum. So when the intensity becomes maximum, we know that is constructive interference, and when the intensity is minimum, that is your destructive interference. So I think now this is clear to you all. So from this we can solve the questions whatever it is asking you in your exam. So now we'll discuss different conditions. So suppose we are doing your constructive interference. So what is the condition for this constructive interference? We should get your cos phi, that will be maximum. So maximum value is your 1. So that is your 0 degree. So cos 0 degree, cos, you know, for the same value of cos, we can put here that the value of cos will be maximum when it is a multiple of, even multiple of, that is we can write 2 pi. So in general we can write here phi is equal to, this is 2n pi, where the n value is 0, 1, 2, like that, right? So in this way we can find out the maxima and the conditions for the constructive interference, right? So here you get, we'll be getting this one as, if we relate this phase difference with the path difference. So you know what is the relationship between phase difference and path difference? This is 2 pi p by lambda. So here you can take, your p will be equal to phi lambda upon 2 pi. So if we take n value as 0, so here you see your this p will be your 0. Then if we are taking the value of 1, that is 2 pi. So 2 pi by 2 pi, this cancels out. So this will come as lambda. So similarly if we put 2, so this will be 4 pi. So 4 pi, so this will be 2 lambda. So similarly we get the points. So here we can tell that the constructive interference takes place when the phase difference is that even multiple of pi, or the path difference is integral multiple of, that is lambda. So I think this part is clear to you all. So similarly we can discuss about your destructive interference. Your destructive interference. So when the destructive interference will take place? When the value of the cos, that will be the minimum. So value of the cos minimum, that takes place at your -1, when the value is -1. So for your destructive interference, here we'll get, that is for destructive interference, you see we have to consider the minimum value for cos phi. So this will be -1. So -1 it takes place, you know, at the value of pi. So this is cos pi. So here we can tell your phi value will be the odd multiple of this pi. So this is pi, 3 pi, 5 pi, like that. Okay, so if you take the path difference here, we can get p will be equal to, that is your 5 lambda upon 2 pi. So for the first case we can get this pi 2, so this will be lambda by 2. Similarly the second case, this will be 3 pi, so 3 pi means pi cancels out, so this will be 3 lambda by 2. So here we can conclude that we get the destructive interference, that is the intensity will be minimum at the points lambda by 2, 3 lambda by 2, that is odd multiple of lambda by 2 at a path difference, and phase difference of, that is odd multiple of pi. So this part is clear to you. So in a interference pattern, in the next class we'll be discussing the Young's double slit experiment, and in that experiment we consider these conditions for the constructive interference or the destructive interference. So now we'll discuss a question which is asked in your previous exam. So now you see, suppose the question is this one: two sources of intensity I and 4I are used in an interference pattern. Find the intensities at points where the two sources superimpose with a phase difference of 0, pi by 2 or pi. So in this question you see we have two interfering waves. So here I can write your I1 is given as, here your I1 is given as, that is I, and I2 is given as 4I. So when they are interfering, we know the resultant I will be equal to I1 plus I2 plus 2 square root of I1 I2. This will be cos phi, right? So here we put the value, so this will be I plus 4I plus this will be 2 4I 4I square, so the square root, this will be 2I, and this is your cos phi. So here this will be equal to your 5 pi plus this is 4I cos phi. So when the two waves are interfering, the resultant intensity at any point which depends upon the phase difference, so this will be 5 pi plus 4I cos phi for this question. So now I think it is easy for you. So different conditions we can put. First one is phase difference is 0. So here we can take the first condition, your I1 will be equal to 5 pi plus 4I cos 0 degree. Cos 0 degree is 1, you know. So this will be your 9I, right? So first part is clear. Now second part, your phase difference is pi by 2. So you know cos pi by 2 is equal to cos 90, that is 0. So this term will 0. So your I2 will come as 5 pi. Similarly for the third condition, if we are putting the value of pi, so your cos pi is equal to, you know, that is your minus 1. So minus 4I. So your I3 will be equal to 5 pi minus 4I. So this will be equal to I, right? So this is how we can solve the questions when it is asked regarding your intensities at a point due to the interference of two waves. This is a very important concept and very easy also. So you understand how we have derived the formula. Thank you.